MCP, Model Context Protocol. What is it? You may have seen this term bouncing around on the internet, and in this video, I'm going to explain exactly what it is. Model Context Protocol relates to LLMs. It relates to AI. So if you aren't familiar with these things, buckle up because I might go a bit fast, but we're going to explain exactly what it is, why it's important, and why if you're currently using language models like the ones developed by OpenAI or the ones developed by Anthropic, this is going to apply for you because this is going to change the way that LLMs and AI actually interact with all the tools that we use on a day-to-day basis. So let's start at the beginning. MCP. It's an acronym, right? For Model Context Protocol. What does that even mean? Well, the first thing you need to understand is exactly what an AI model is actually doing. LLMs at scale are trying to do the most accurate thing for the human. To massively overcomplicate things, AI is effectively trying to figure out what it is you exactly are trying to look for and tries to optimize the output to generate exactly what that is. But there is a problem. AI has been getting smarter and smarter, but when it comes to actually using things, it isn't the best. Now, personally, I've been a front-end software developer for almost 7 years now, so I know a thing or two about designing user interfaces. The thing is, user interfaces, or GUIs, which stands for Graphical User Interface, are typically designed for humans. They are meant to make the actions that we take on a computer simpler. If you have a button here, if you have an icon here, if you have a window here, these are all things designed specifically for humans to make it easier for us to navigate interfaces. Because that's the thing about user interface design. Ideally, you're designing an interface that's really easy for a human to use. And up until this point, we really haven't had to have anybody else other than humans use a user interface. Why would we? The thing with computers is that they function a lot more efficiently than humans, and it's a lot easier for them to do tasks at scale when it comes to creating things, reading things, updating things, deleting things, because, well, they're computers. They don't need to have our eyes and figure out exactly where to put the buttons so that it makes sense for our human brains. And again, up until this point, we haven't had to adjust that. But this all changes when we have LLMs. LLMs do not like interfaces. If I've ever designed anything, it's always been for a human's eyes. It's never been with an LLM in mind because up until this point, LLMs didn't exist at scale. But now we're moving beyond just chatbots and things like that to actual full-on agents that can actually do things at scale. They can interact with user interfaces, right? No, they can't, because the thing is, most user interfaces are not very friendly for LLMs. They like text. They like text a lot more than anything else. So what do? Well, this is where we get into a little bit more of a complex topic if you're not a developer, and it has something to do with APIs. APIs, essentially, if you're a non-techie, are the way in which information is interacted with between the interface, being what the human interacts with, and the backend, which is basically where all the algorithms are happening, all the storage is taking place. That is the connection. Think of it as the bridge between when the human clicks on the button, the information about what that button should do, and the pipeline in which it sends that information to the backend and returns a response. Now, once again, up until this point, there's never been a reason to change that function. Humans see what they want to see on the front end. They click a button, they sign out, they enter pieces of information in, they do whatever they need to do on the interface designed for a human. That information gets sent along the API, either retrieving data or sending the data, all that stuff, sending it with the backend. It's effectively storing and retrieving information. But the thing with LLMs is they don't work off of those same user interfaces that are designed for humans. They work off of text. But the issue is there are so many different APIs, so many different pipelines between the front-end interfaces of your favorite apps and software to their backends. So what's the solution? Just teach the AIs how to use the APIs, right? Well, there's a big problem with that. Let me give you an example. Let's say, for example, that I wanted to create a simple application where it's an accounting software. It adds numbers together and it saves those numbers. It doesn't matter what the user interface looks like. It doesn't matter how the APIs are set up. What happens is when I need to connect it from my front end to my back end, there are certain contexts that need to be put in place. There are certain credentials. There is a whole bunch of information that needs to be transferred and set up ahead of time in order to ensure that that connection from the front end user interface to the back end works correctly. And as a human, that's pretty easy because you understand the context of things. But LLMs have a little bit more of a difficult time because as much as you could give them the documentation and they could kind of understand how that works, they aren't grasping the full reality of how that works. This is exactly where Model Context Protocol comes into place because it acts as almost a middleman, a translator, if you will, between the front-end user interface that the human sees and the actual action that needs to be taken by the LLM automatically. So let me explain here. So before, we're talking about just the LLM looking at the user interface. It has a hard time doing so and has a hard time executing the particular task. Model Context Protocol is effectively a way that it sits as a middleman. So when the LLM is told to create this or do this, it automatically talks to, instead of directly the backend, the Model Context Protocol. So let's imagine this scenario. The LLM says, hey, I want to create a new task in any particular application. It could be on a CRM, it could be on an accounting software, it could be on anything. Now, how is it going to go and figure out what API it needs to fire off with which application and which credentials, and does it have to have a certain number? There are so many variables that go into each different one, and the AI or LLM isn't going to go and read the entire documentation every time or store that, and it's really inefficient. This is where the MCP comes in. The MCP is effectively a big library of all of the tasks that the LLM could potentially take and exactly what API needs to be fired for that task to be successful. So let's say, for instance, that I train an LLM or an agent to automatically take everything that I get in my email and create it as a new task in ClickUp, for instance. ClickUp is the CRM that my team uses in this case, and I train the LLM to do that. Well, typically, what you would typically have a human do is set up the credentials between, ClickUp's backend and the front end that you're doing and whatever sort of automations you're trying to have set up in place. But with an LLM, it gets much trickier because you can't just go from an LLM straight to the backend the same way you do with a human. In this case, if I've told the LLM that I want it to create a task, it says that to the Model Context Protocol. The Model Context Protocol already knows the exact credentials that need to be sent to ClickUp. It knows exactly how the JSON data should be structured. It knows exactly what information needs to be included in what particular request for that to be successful. And so it says, don't worry, buddy. You told me that you wanted me to create that with that title. Okay. It translates it effectively and it creates it. On the surface, it looks like magic because the LLM talks to your MCP, the MCP talks to your backend, the task gets executed successfully, and exactly everything works as it's supposed to. So I hear you asking yourself, Josh, okay, that's well and good. MCP is a glorified translator. It effectively takes the information about what the LLM wants to do and puts it to the right backend and API and all that. But what's so special about this? What's the reason why this is such a big deal? People are seemingly freaking out about this. The answer to that is, think about how many different LLMs there are. Think about how many different companies there are. Think about all of the AIs that have been trained on different data sets that are all trying to execute the same sort of tasks. You can imagine that if I lined up Claude, if I lined up any of the OpenAI APIs, if I lined up Gemini, if I lined up pretty much every LLM that exists in the world, and I gave it the same task, create a task in ClickUp that does this thing. Well, they would all probably do it in a slightly different way. Some of them succeeding, some of them failing, and some of them probably getting halfway or maybe doing it half right. At the end of the day, there's so much room for error here simply because of the fact that there is no standardization across the board. Now, we introduce the MCP. Keep in mind, the original situation we were talking about was if an LLM is talking strictly straight to our backend. And again, each backend, each tool has its own configuration, its own credentials. You can imagine that it's not really possible right now for an LLM to have access to every single possible type of credential, every single type of context for creating, reading, update, deleting for every tool on the planet. It's just not feasible. But this is why an MCP is such a big deal, because it standardizes things across the board. This means that if you want to create a new task in ClickUp, instead of the archaic way of things, where the LLM would just haphazardly try and figure out exactly what it is that makes a task get created in ClickUp and tries to read through the documentation, think of it like a developer who has no idea how to do anything, throwing a bunch of papers in the air. It wouldn't really work. Maybe they get lucky some of the time, but maybe they wouldn't. But now the MCP is there. And they simply say to the MCP, I want to create this new task. I want to update this new task, delete this new task, whatever it may be. And the MCP says, yes, okay. The MCP goes, finds the particular, if we're assuming this is a library metaphor again, it finds that particular book that says, oh, this is how we add a task in ClickUp. The JSON data, the credential data, all the information is contained right there, and it fires it off. It gets created. On the surface, it's perfect, but it only would have happened because the MCP was trained ahead of time. It doesn't matter whether you're using ChatGPT, Gemini, or any other LLM. Because of the standardization, because of the MCP, it effectively makes it so that you could use any LLM on the planet to do the particular task across any type of product or service or software that supports it. And that's a really big deal because it brings the margin of error down. It shrinks it. MCP standardizes tools. That's the whole purpose of it. It's meant to make sure that no matter how many LLMs are developed in the future or how many different pieces of software are going to continue to be built, effectively, at the end of the day, if you have an MCP in, it makes it the most efficient way to use an LLM to accomplish a task, whatever that task may be. Again, creating, reading, updating, deleting, doesn't matter. So why does this matter to you? Well, first of all, LLMs are a big part of the growing world of technology, and to be honest, I don't really see a world where we go back to not having them. The technology is just too great for where it's at, and I only continue to see it getting better and better and better. But that being said, there is a lot of uncertainty. There's a lot of variables. Every single LLM can be trained in its own individual way, but they're all competing with the same tools and software. Ideally, the world with MCPs is better because of the fact that we're standardizing access to those tools across the board. Because in this case, it doesn't matter what new software or tools exist in the future. All you would have to do is have that new tool or software have an MCP server that automatically is able to interpret, translate exactly what the request from the user is or the request on the agent side from whatever the LLM says. Doesn't matter what type of content it is, creating, reading, updating, deleting. All that matters is it able to effectively communicate what needs to be done to the MCP? And does the MCP have a route, an API, that can effectively get that done in the backend? So great. At this point, you should understand the basics of what an MCP is. It's effectively a translator between the LLMs and what they want to do and the actual way that those are performed on the backend side of things. So why is this such a big deal? Why are people hailing this as a new innovation? Well, one of the biggest things is everyone's agreeing to it and everyone's cooperating to make it work together. Now, this is going to be a massive oversimplification, but think about it like this. Every single phone that has Wi-Fi in it, or a chip that can connect to Wi-Fi, at some point in time, all of the phone providers must have said to themselves, we want Wi-Fi in our phones. So we're going to build a technology that can connect to Wi-Fi and make it all work. Again, massive oversimplification, but it means that a cooperation was put in place that everyone agreed to a technology that made everything better. That's why it's become a universal standard across the board for Wi-Fi to be in phones, for Bluetooth to be in phones, because they're technology that exists. If a phone didn't have Wi-Fi or a phone didn't have Bluetooth, you wouldn't buy it because it's like, what? And that's what's happening with LLMs and MCPs. MCPs are becoming the thing that allows any LLM, the ones that aren't even created yet, to automatically connect to any piece of software. In the early days of ChatGPT, when you would go and ask ChatGPT, hey, can you send an email for me? Or hey, put this in my calendar. ChatGPT would most often come back with a response of, I'm sorry, I'm a large language model. I don't have access to your apps. But the difference here is this. The reason it declined your request is because it didn't have anybody to talk to. It didn't know how to do that. We all know what happens when an AI doesn't know what to do, and it often makes stuff up or hallucinates. If ChatGPT had access to all my apps and I told it that I wanted to put something in my calendar, it wouldn't exactly know what to do, but it would try its best, and that could lead to some disastrous consequences. The MCP solves all of that, and everyone's agreed to it. It means that when I ask ChatGPT to go put something in my calendar, ChatGPT understands what the request is. It's to put whatever I've asked for in my calendar, but it's not the one sending that request off, because it doesn't need to. All it needs to do is communicate that intent to the MCP. It says, hey, MCP, I want you to put this in this person's calendar. And the MCP knows how to interpret that information and actually do the thing. It's effectively taking the intent or the context from the model. You're starting to see it now, model context, taking the context from the model and executing the protocol to get that thing done. That's why it's called MCP. It's taking the model's context and taking that context and actually executing the protocol. If you've been confused up until this point, hopefully that makes things a lot easier. It's a translator between a language that ChatGPT, Gemini, Claude don't know how to speak, actually executing on what the intent is, and taking that context and actually executing on the thing so that no matter what you're trying to build or no matter what application you're trying to interact with, you have an easy way to do it from any LLM on the planet. And by the way, This only happens because of the cooperation. MCPs may have been started by Anthropic, but they've now been adopted by Google, Microsoft, OpenAI. All of the biggest tech companies are coming on board because it just makes sense. It standardizes things across the board. I think personally, in the next couple years, we're going to see MCPs for every application. This is what really takes LLMs from just being the simple chatbots that, validate your emotional needs and, teach you how to code and help fix your bugs and just do everything that you would do with a typical chatbot, and actually become that full sci-fi assistant that we've seen in the movies. If I say, hey Jarvis, I want you to send an email to Pepper Potts and I want you to prep the Mark IIIs and I want you to, all of those things, it now knows how to do. Because instead of Jarvis just understanding, well, okay, I know what the suit is, I know who that is, it can interact with a translator that can take the intent that the AI, the LLM may understand and actually translate it into action. And I think this is going to be sweeping across the board. We're going to see it in our physical hardware and obviously in our software, because now we have a way to actually get the LLM to execute. At this point, it's just going to have to be the context that we provide the LLM, which context is actually already pretty good because LLMs are already trained on something that understand what exactly the context we're looking for is. If I say, send an email to this person, that LLM's only issue is going to be what we have now. If you have two people with identical names in the contacts. This is really where things get full sci-fi. Because think about it like this, using the example of Iron Man and Jarvis again. If Iron Man asks Jarvis to send a message to Pepper Potts, and Pepper Potts is in Tony's phone twice, there's two different contacts with two different numbers. Jarvis wouldn't go ahead and just send out the email or send the message to both of them or try and just figure things out. It would ask Tony again. It would say, hey, which person were you trying to send this to? Was it this number or this number? Gets the response back, it's clarified the intent, and then instead of going and interacting directly with that software, it simply plugs into the MCP. It says, okay, I know how to send a message, I know who I should send it to, I plug that data into the MCP knows exactly what to do with that information, it fires off the request, and from the human level, it looks as though it's happened by magic. So what's the catch? Well, as much as I love this new technology, there definitely is one. First of all, by allowing an AI to connect to an MCP and actually execute on a particular create, read, update, delete, we leave room for the most problematic thing of all, misunderstandings. Because there's a big difference between asking your AI to do something and then your AI saying, oh, this is how you could do it in the best way possible, and then asking your AI to do something and then it actually doing it. If you say, hey, I want you to go ahead and just delete all of the old presentations off of my Google Drive for this particular project, the AI might misunderstand what all of the old presentations mean and go, oh, every presentation that was created before this instant, this moment, should be deleted. Okay, sends that information to the MCP. The MCP goes, yep, okay, I know exactly how to delete files in Google Drive. I will delete all the ones that you've requested, fires that off, and it doesn't work. Now, this is what's known as the confused deputy problem. Your AI may have the ability to do something, and that might work perfectly, but if your AI fundamentally misunderstands what your intention is, it may accidentally tell the MCP the wrong thing, and the MCP, working as it should, fully does something that you weren't intending to begin with. Now, this sort of thing can happen even if you aren't actually being maliciously attacked, because if the AI simply misunderstands what you said or misinterprets it because you were a little bit vague. If I say, hey, fix that file from earlier, and it doesn't know what file to fix and it just decides on a file, it's still going to communicate with that MCP, and that MCP is going to work flawlessly because that translation is effectively taking what the AI says to do and then just doing it. But if the AI is wrong, that could lead to some big consequences. And then again, on the malicious side, what if an AI accidentally connects to an MCP that's not really Google Drive? It thinks it's connecting to the MCP for Google Drive, but it's connecting to a malicious hacking MCP. Whether that gets put in place by malicious hackers or you clicked on a phishing link and that got inserted and switched around, who knows how it could happen. But at the end of the day, if we're putting forward this technology where AI is actually able to execute real things in the back end, creating information, reading information, updating, and deleting information, there are going to be situations where it either misunderstands things and gets the MCP to fire off the wrong thing, or is maliciously hijacked so that instead of actually executing it on the MCP that you want, it's executed on an MCP that is actually malicious and could potentially steal your data, which is why we have to be extremely careful about it. But for the most part, MCPs are going to change the game across the board. The ability to tell an AI to, hey, book a flight to Japan for me and make sure that it's under $1,500. And it just sits there all day and looks and looks and looks until it finds the flight that matches the requirement that you've asked for, tells the MCP, book that flight, and then it books it. That is a real reality now. And honestly, people are going to have their own personalized LLMs that connect to MCPs from every application and company on the planet. If a regular human can use your software to do something online, make a purchase, create a new piece of information, download anything that a typical user interface would be used for, well, it's very easy to set up an MCP that allows any LLM to plug in and do the exact same thing. The difference is it is going to be much more efficient simply because we don't need to use our dumb human brains and eyes to figure out where on the interface the buttons are and the filters are. The AIs already have all that information and they are much faster at executing it. And now they have a way to actually not only tell you the best way to do it, but do it themselves. And that, my friends, is why MCPs are an absolute game changer. Model Context Protocol. A simplified, universally adopted way to allow any LLM that exists today or will be existing in the future to accurately connect with any tool on the planet that exists today or will exist in the future. Of course, you do have to build an MCP that actually translates, but once you do, sky's the limit. And there you go, MCPs in however many minutes this was. Hopefully, this gives you a lot more of an understanding of exactly why this is such a big deal and why I'm sure you're going to be hearing much more about MCPs in the future. As always, thank you so much for watching. My name is Josh Mountain, and I look forward to seeing you in the next one.